Start recording. Good morning. It's Friday, October 18th, 2013. This is geometry, first period at the Washington State School for the Blind. I'm JJ, the instructor. We have two other students present with us today. Abby Griffith. Oh, yep, three other students. Sorry. Totally forgot. Brian.
Hi.
And Stormy.
Stormy's phone.
All right. We're finishing up section 3-5 in our geometry textbook, complementary and supplementary angles. So we started yesterday. We are on D117 in Braille and page 117 in print down towards the bottom of the page. Very quickly, let's review a little bit. I asked you guys to go home last night, and all your homework was to memorize complementary and supplementary angles, right?
Yep.
Okay.
Yep.
So, Stormy, what are complementary angles?
Two angles that add up to 90 degrees.
Awesome. All right. I already quizzed Abby when she came in earlier this morning, so she's off the hook. Bryant, what are supplementary angles?
Angles that have a sum of 180 degrees.
Excellent. Do the angles that are complements or supplements to each other have to share the same vertex?
No.
No.
Good. Do they have to share a common side?
No. No.
No. Can they just float out in space somewhere?
Yeah. Yes.
Good. All right. What is the measure of an angle that is a complement to a 30-degree angle?
60.
60. Good. 60 and 30 complements, right? What is the measurement? So, Abby, now you're on the spot. What is the measurement of an angle that is a supplement to an angle that measures 100 degrees? 80. There we go. All right. Good job. Nice review. Okay. So that's the easy part, really, isn't it, with all the words? But where we want to work is with all these tactiles and these graphics to figure out what they're asking us to do based upon looking at a drawing. So you have a drawing in the middle of D117. Let's make our way around this drawing. Looks like we have 1, 2, 3, 4, 5 rays. And we have a kind of like a center vertex, I'm going to call it. And they've labeled that center vertex T. That center vertex is labeled T. And let's start at that center vertex. Also, right above T, notice that there's a square indicating a right angle. So in between those two rays, at the top, so we have ray TP, so P goes through about 10 o'clock. EP, that's one of our sides of our 90-degree angle.
Is it T you talking? Oh, okay. That's a 90.
T, and then T, then go through about 1 o'clock through TF.
Where's T? Where's T? Right there.
Yep.
All right, so that top angle, PTS or STP, they have a right angle indicator in the midst of that one. So that's a 90-degree angle, correct?
Yes.
All right. Then let's go back to T and go just slightly below the 3 o'clock position through ray TV. They've labeled it right above the point. TV.
Okay. Yeah.
TV.
How come VT is not there? SP.
What's it? Where are you? You're okay.
Where's
P.
the T?
Where's what? T?
Yeah.
Oh, so it's right in the middle. It's your vertex, and they've labeled it just below it.
Here.
There you go. Yeah. Okay.
I know.
Just below it. They never really have a consistent area where they put the names of the points. You just gotta search around. Yeah.
Actually, I was searching this area, didn't go middle. That's
yeah.
why I didn't find it.
All right. Typically, a middle point, they're going to try to have it close to the middle somewhere, but sometimes they put it on the top. of the vertex, the right, the left, the bottom. You just never know. So you got to kind of search around for that capital indicator and the letter. All right, so we have TV as a ray TV going through just below 3 o'clock. Then go back to T and go through between 4 and 5 o'clock. And we go through point R. So we have ray TR. So we've created an angle there, haven't we? How would we name that angle?
Which one?
V, T, R. And how else could we name the angle?
RTV.
RTV. Good. All right. So we've looked at 3 angles so far. We've looked at PTS or STP. Then we looked at STV going from about 1 o'clock through 3 o'clock, or VTS. And then now we've looked at VTR or RTV. Now, in the midst, in the interior of those 2 angles, so the first angle was 90 degrees. Then the angle immediately to the right, STV, how many degrees is that?
60.
60 degrees. Excellent. Uh-oh, my phone's ringing. Hold on. Oh, small marathon. Okay. All right. Bye.
Okay.
That was really important.
Okay.
One of my senior students was going to the coffee shop this morning, and he wanted my order. Very important on a Friday.
Very important.
All right. Okay. Yes.
This is 90.
That's 90.
No number, but this is works. Yes.
Right.
It's a 90. Right?
Yes. Abby asked. Abby was pointing at PTS or STP, and she said this is 90 because of the square, and they don't put the 90-degree measurement in that area, and that is correct. They'll just put the little square. All right. So 60 degrees for STV or VTS, and then what's the measure of VTR or angle RTV? 30 degrees. Good. 30. All right. Then go back to T. So we had TR, that ray. Go back to T and then go through about the 8 o'clock position through point Q. And we have another ray. And then we create an angle RTQ or QTR. How many degrees is that angle?
120.
120 degrees, right. Okay. And then finally, we have QT or TQ, ray TQ, and then we're back at where we started up at the 10 o'clock position at TP. So you have that angle.
Supplementary.
Yeah. Oh, you were already being all fancy. You figured out the supplement to that, didn't you? How many degrees is QTP or PTQ?
You said Q. What is
QTP
QTP
or
100,
PTQ?
180.
Oh no, but we want to know the angle in the interior. What does it say?
Is it
60 degrees.
60 there? And
Yeah, and 120. Then together they would create 180, which is supplementary, correct?
Mhm.
All right. So now let's put even before we read what they want us to do on this, let's just push ourselves and think a little bit more, putting our Euclidean geometry brains on and what we know so far. We know a lot of stuff. We need to give ourselves credit for all this stuff that you're learning so far. You have named a whole bunch of angles. You always name an angle with a vertex in the middle.
Yeah.
You can name them frontwards and backwards, right?
Mm-hmm.
In this particular drawing, this tactile, there's a 90-degree angle. You've learned that indicator. Then you've learned all the other different, the degree indicators. You probably already knew it, but you're getting to remember that. You've also learned some rules about angles. especially adjacent angles. So there's several adjacent angles going on here, aren't there? What's the rule of an adjacent angle? What are the two rules that have to remember?
They share common side and common vertex.
Common side and common vertex. Well, all of these have a common vertex, don't they? The vertex is T. So if we wanted to name adjacent angles, we would just have to name them based upon their common rays. And we could start at the top left at TP, and we have that PTS angle, and then right next to it is STV, right? Correct? To the right of it. Those are adjacent. Or we could go to the left of it, and they could share the ray TP, and we could have PTQ as an adjacent angle to it. You see that?
Yeah, they share.
Yeah, they share that common side TP. Or we could go to the angle to the right starting at S, which is at about 1 o'clock. So our STV angle, it's adjacent to the next one to the right, which is VTR, isn't it? All right. And then we could start at angle VTR, which is the one that's about through 3 o'clock to 5 o'clock, VTR, and it has an adjacent angle immediately to its left, RTQ, right? RTQ. And those two angles together, VTR and RTQ, what's the total dimension of their angles? Total measurement of their angles. So VTR is how many degrees?
Which is this one?
Nope.
30.
30. Yep. VTR is 30. And then RTQ is how many? 120. So they make the big, huge angle VTQ. See that? They make this big, huge angle V just below 3 o'clock, T, and then Q at about 8 o'clock. Those two combine to make an angle that's how many degrees? 150. Excellent. All right, because we used, and then what we just used now is the angle addition postulate. Remember that from a while back? Angle addition postulate. So you just use that to figure out the measurement of a bigger angle. All right, then from our 120 degree angle, so our RTQ angle, we go clockwise and we go through, we find QTP adjacent to RTQ. QTP is.
This one.
Okay? And then it shares that vertex T, it shares the common side TQ. What is the measurement of QTP? 60.
60.
Yeah, and combined with RTQ, what is that total?
210.
Oops, 60 and 120. Sorry, not the VTQ. Yeah, not VTQ, but RTQ. 180. Excellent. Now, what else have you learned about angles, and in particular these two angles? They're adjacent, but what else are they?
Linear.
Linear, that's right, because they share a common vertex, they share a common side, and their non-common sides, or their non-common rays, that TR and TP are opposite rays. And you learned, I think it was in section 3-1, that opposite rays form a line, right? And a line, if you go from one side of the line and arc your way around to the other side of a line, you've created a really big angle, this RTP angle, this straight angle, and that is 180 degrees, isn't it?
Yeah.
From R all the way to P, if we arc, if you just draw a little arc with your fingers from R to P, you've got 180 degrees. Have you ever heard this statement, do a 180?
Mm-hmm.
Yeah, what does that mean?
Turn around.
Turn around, exactly. So from point R to point P meant you turned around, right? You were facing forward and then you immediately turned and faced the other way. That's a 180. In a car, when you're driving in a car and it's a crazy move in cars where they do spin moves and stuff on the movies, a car will do a 180. That means they stop really fast and turn their wheel really fast, and the car immediately turns around and faces the other direction. And that's a 180. What happens when we do a 360?
That's all the way.
All the way around. That's right. So if we added up all of these angles, what should we get? 360. 120 and 60 is 180. 180 and 90 is 270. 270 and 60 is 330. 330 and 30 is 360. We better, right? We're going all the way around it. Yeah, isn't that cool? So lots of stuff going on in this drawing that you have learned over the last several weeks. You've learned over the last 2 months. I mean, you've learned, we started out on lesson 1 learning about a point, right? There's a whole bunch of points on this graph. Then we, you walking off with my change, dude?
Oh, right. Yeah.
There he goes.
Just trying to take.
Yeah. Gabe went to the coffee shop and he took a $10 bill and he's like, "See you later." See you later.
See you later.
Gabe, this is online is Stormy from Kennewick. Have you ever met Stormy?
Hi.
Hearing yes?
No.
No. And then Brian. Thank you.
Hi.
All right. All right. Thank you, sir. Yep, bonus points for you. You can keep that.
Is that expensive, that coffee?
No, actually, it's pretty cheap.
You know?
Really? I want to stop
Yeah,
there.
hers was $1.
Nice. All right, so here we are. We have just put our brains on and applied all sorts of things. We learned about points. We have 2 points making a line on this, the P and the R, right?
Mm-hmm.
We have 3 collinear points on this graphic, don't we? What are our 3 collinear points? So remember what collinear means and find your 3 collinear points. Yeah, what do you got them? You got them, Abby. Tell us what they are.
I don't know.
Okay, what's that top one?
This one.
Okay, feel the point name.
P.
P. Okay, and then what's your middle point?
T.
T. And then what's your R? Exactly. So P, T, R are 3 collinear points. Remember, long ago you learned that collinear means they all got to be on the same line, right? Colline.
Yeah.
Okay. So we got our points. We got 2 points making a line. We've got 3 non-collinear points. We have 3 collinear. Excuse me. We have 3 non-collinear points going on all over this thing, don't we? Yeah. Yeah. Anything that's off of the line then becomes non-collinear, correct? What happens when we have 3 non-collinear points? What have we created? A plane. Yeah, a plane. Excellent. Yeah, and so this has created wherever, like PTS, that created a plane. PTV, that would create a plane. Yeah. Not angles, it creates a plane, which is kind of a theoretical thing to quote unquote look at. You have to just trust that there's infinitely many planes slicing through the air. This page on the book is a plane. All right. Then you learned about rays. You got to have an endpoint, right? How many? We have a whole bunch of rays going on in this particular drawing. More specifically, we have 5 of them creating the angles that we wanted to work with, right?
Yeah.
Yep. And you always name a ray. How do you name a ray?
Starting with the endpoint.
Starting with the endpoint. Excellent.
So TP.
Yeah. That's one of them. Oh, that coffee's good.
TQ.
TQ, yeah.
And
TR.
ER, good, yeah.
TV.
TV. TS. You got them. Who would ever thunk? All this information, huh? Then you learned you put 2 rays together at a common vertex point and you've created an angle, right?
Yeah.
So we got bunches of angles going on here. We got the angles that, they put measurements in, but we could take any 3 of these points and create, even more angles. We could create PTV. We could have the straight angle PTR. We could have a huge angle PTQ. That's a huge angle. PTQ. You go PTQ. What you do is it's the exterior of PT of the other PTQ. So it's very hard to we're going to get to that later, but we can put our brains on it about now. But you can you have PTQ at 60 degrees, but you could also go around it on the back side, basically, on the exterior, and you have this huge angle going clockwise from P all the way around to Q. And so you have 90 and 60 and 30 and 120 that you add together. You have a 300-degree angle going on there. See that? Because it's the exterior of the 60-degree angle on the inside. Isn't that cool? Mm-hmm. You'll learn that later, but we can talk about it now. Who cares? All right. And then what else have we learned? Let's see. We've learned about right angles. So you learned a right angle indicator, 90 degrees. You've learned about the measure of angles, how you measure angles. Right. And then you've learned that you can put you put two angles together that share the same vertex in a common ray, and you have adjacent angles. You put two angles together that share the same vertex, a common ray, and their non-common sides go in opposite directions, and you have a linear pair, adjacent, and then a linear pair. And then now we're applying the skill of complements to each other and supplements to each other. Holy mackerel. All that information in that one drawing. Woo!
Yeah, a lot.
I know, that's practically the whole book so far. Nicely done. Okay. Is this in the video too? What? Oh, you want this video also? Sure, you can have the video to refresh your brain. I'll just start sending links to all of you of the video for the day, okay? In case you have nothing else to do and you want to listen to geometry. It's all good. It makes my little math heart pitter-patter that you want to listen to geometry. You know, and it might be a new technique for falling asleep at night. Yeah. You could turn on your YouTube video of JJ talking about geometry and I could lull you to sleep. All right, rockabye, Abby.
No way.
Into line land. Angles and measures, points and planes too. I know. What's wrong with me?
Yeah.
I'm crazy. I'm silly pants. All right, here we go. What do we have to actually do in this example? It says down below, the measure of STB plus the measure of VTR equals 90 degrees. Yep, we figured that out. STV is 60 and VTR is 30, so those two are 90, so they're going to be complements, aren't they?
Yep.
Also, notice that they're adjacent. There's another set of complement angles in this drawing, isn't there? They're non-adjacent. What are they? Well, a bunch of, but take a look at your measures of your angles, and there's another set of angles that are complements. And remember, complements don't have to be adjacent.
So, PTS?
PTS is 90, so it's all by itself. It's not a pair. It's just by itself hanging out at 90 degrees. So it's just a right angle. It doesn't get to be a complement of itself.
TVR?
Okay, which one?
TVR?
TVR?
Q.
Q. QTR is how many degrees? 120.
120.
Yeah, QTR is 120, so that's not going to be a pair with a complement. There's two angles that are complements to each other. Uh-oh, Abby thinks she's got it.
Is it like QTP and...
QTP, yes, QTP is 60.
And VTR.
Yes, awesome. All right, everyone. Bryant, Stormy. QTP, it's the angle immediately on the left. It goes from about 8 o'clock through about 10 o'clock. That's 60 degrees. And then On the right-hand side, you have VTR or RTP. That's a 30-degree angle. So those two angles are also complements to each other, but we call them non-adjacent complements because they don't
One
share.
point that way.
Mm-hmm.
Oh, they share vertex.
They share the vertex, but they don't share what?
They don't share side.
They don't share a common side, correct. They don't share a side. But they still get to be complements of each
Yeah.
other.
Yeah.
All right?
Good.
Excellent. All right, turn the page. Now we do the same work with this drawing, but we're gonna think about supplements. Supplementary angles. So we're on, it's a page break on 117E and it's 118. And there's a drawing right in the middle. Let's make sure all this stuff we can read on it here. We have a center point, a vertex, and they're labeling that point F. It's kind of bottom right of the angle, point F.
Mm-hmm. Point
Okay.
F. Right, there's the middle.
So find your middle. Now at your middle, I want you to follow the ray up through about 10 o'clock. And you're going to go through point B. They've labeled it just above to the right, point B. So that you have F ray FB. Go back to F. I'm going to go clockwise and go through about 2 o'clock through point C. Okay. Now that's an angle, BFC or CFB. How many degrees is that angle? 120. Good. All right. Go back to F. And again, we're going clockwise, so we're going to go through about, almost 4 o'clock through point D. They've labeled it just above the point to the right. How many degrees is CFD or DFC?
45.
45. Good. All right, go back to F and then go down through about 7 o'clock. All right, and we go through point E. They've labeled that to the right of the point. So we have angle DFE or EFD. How many degrees is that angle?
105.
105. Good. 105. How you doing, Bryant?
Good.
All right. Go back to F and then go almost, it's just slightly below 9 o'clock, the ray, through point I. And they've had to put point I, they've used a little teeny tiny dash line, you probably can't even hardly feel it, to the left, to the top left of it and said point I. Can you find it?
Yeah.
Okay. And then, so that's EFI that we're looking at. So we're looking at the bottom left angle that's adjacent to the 105 degree angle, DFE. What's the measure of EFI?
Yes, I know.
60, Abby says. Yes, 60. So EFI on the interior of it is 60 degrees. Then finally we have the last little angle that makes our entire rotation. That's IFB or BFI.
That's an A, I think.
Oh, it's an A. Thank you.
I'm like,
You're right.
CI.
It's an A. You know what I did? Did you see what my brain did? Thinking it was an I? I joined together the six dot and the
Okay.
and
I'm
because,
like,
I know because I'm looking at it
I was looking
and not reading it tactily, my brain thought that was an I, but there's big
Yeah, that's
space
an
in
A.
between it, isn't it? And it's an A.
it's hard to feel though, because the dots are ripping off.
Yeah, they are. But I look at this rather than feel it, and so my brain picked that up as an I and not a capital A. That's kind of funny. All right. So,
They put these
yeah, they put that little teeny
for-
arrow to say that that's point A, correct.
The measure of that is 30, isn't
It
it?
is 30. Thank you, Bryant. Yep, 30 degrees. All right, and then if we added all these up, what are we going to get?
360.
360, exactly. Okay, but they're asking us to find supplementary angles, right?
Yes.
So what two angles would be supplementary to each other? Yeah.
Yeah.
Abby thinks she's got it.
So AFE.
AFE is 60 degrees, yep.
BFC is
BFC is 120. Abby, you're getting this. Nice. All right, Stormy and Bryant, find AFE.
AF.
That's the one kind of bottom left, 60 degrees.
Mm-hmm.
And then find kind of the top angle, the big fat obtuse angle, BFC. Oh, that's another thing we didn't talk about is obtuse and acute, right? We've learned that. So the obtuse angle at the top, BFC, is 100 degrees. And those two together are supplements. Are they adjacent?
Try to find another one.
No, they're not adjacent. They don't share what?
common side.
Common side. Good. Good, good, good. All right. Okay, let's see here. What else?
Yeah, so you go E, F, D. Mm-hmm.
Got it, Stormy?
Yeah.
Cool. All right.
Right.
So let's turn, let's see, they have another tactile 2 pages over. Same things going on here. I think you got this, so I'd like to move on to the next example, example 4, which is actually on 118C, I think. Yeah, okay. We got to do a little bit of algebra.
I found 18C.
It's not too bad. You're going to think, oh, okay, no problem. But let's think about it as we prove it, too. Let's be proof writers. So,
Do I need flowers?
no, we could just talk through this one because it's all written out on your page. So it says if you have angle A and B are complementary, and the measure of angle A equals X, and the measure of angle B equals 5X, they want you to find X and then find the measure of angle A and angle B. So you don't even need a tactile for this. You're just going to put your brains on and go, well, what were all the key things they told me? So they said angles A and B are complementary. So what does your brain immediately do if you hear that?
We know that it has to be 90 degrees.
They have to add up to 90. So they show that in the proof that they write out. They say the measure of angle A plus the measure of angle B equals 90 because of our definition of complementary angles. You see that? So they're proving this. They're writing it all out. Then the next step, we're going to plug in, aren't we? The measure of angle A is X. The measure of angle B is 5X. So they use what property to do that?
Substitution.
Substitution, right? We get to substitute the values. So they write X plus 5X equals 90, and they say why. It's the substitution property. Okay, substitution property. Then we do a little algebra, don't we? We got to combine our X and our 5X, and that makes 6X equals 90, and that was a algebra tool called combining like terms. They even state that, combine like terms. Then if we have 6x equals 90, how do we isolate x?
Divide.
Divide. So we have to use the division property of equality and divide both sides by 6x, and x equals 15. So we're done with the first third of the problem, right? We discovered x. Then they want us to name each angle, the measure of each angle, now that we know x. So we go back and we go, all right, that's right. The measure of angle A equals x. So what's that going to be? 15, right? And then the measure of angle B is 5x. So we substitute in 15 and go 5 times x for 75. Or, because we knew they were complements, we could take 90 and subtract 15. We'd still get 75, right?
Mm-hmm.
Okay? So there's a couple ways you can do it. So you'll have little problems like that. That's probably an example of an end-of-course exam problem, where they won't necessarily, they'll just give you a bunch of words like that. They'll say two angles are complementary or supplementary. They'll give you some sort of algebraic expression for a measurement for each angle. Your brain has to go, okay, I need to add both of these together and equal 90 or equal 180, and then I need to just do some basic algebra to it to solve for x. What you need to be very careful of is making sure to read if they want you to find the value of x or they want you to find the value of the measures of the angles. And they most likely will trip up those numbers in the answer choices. And so you need to be very careful. A lot of students will find that x value and then won't go any further, and they'll just go, oh, it's 15, and they wanted to know the measure of the angle instead. All right? So be super careful about reading what they want. All right. Let's see. Turn the page. We have another postulate. We kind of already talked about this 2 pages. Want to be 119 straight up. We already talked about this a little bit. We put our brains on this morning and we went through that drawing and we talked about linear pairs, and that if we went from one point on our linear pair and drew an arc to the other point, how many degrees have we gone? 180, right? Mm-hmm. So this postulate, it says in the figure angle WUX and XUY form a linear pair. So the U is your vertex. W is at about 8 o'clock. WUX. X is at about 10 o'clock. And then XUY. Y is at about 2 o'clock. Those form a linear pair. So you can see that because UW and UY, those are your opposite rays forming a line, right? And then they share that common ray UX. And so those two are a linear pair. And postulate 3-4 states that if two angles form a linear pair, their angles are supplementary. And we already figured that out earlier. We said, hey, if we were to go from point W and arc our way all the way over to point Y, we've turned around. We've gone 180 degrees, right? Yeah. So postulate 3-4 on the next page, it gives you a graphic, and in words, it details if two angles form a linear pair, then they are supplementary. So they've done that conditional statement, the if-then, right? Yeah. So we've done some observation, we've done some thinking about this, and we've said, well, yeah, duh. If you got two angles that are a linear pair, they're going to form 180 degrees, and their 180 degrees is supplementary. So always, 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 linear pairs are going to be supplementary. So we state that in a postulate. There we've just proved something, haven't we, based upon all the knowledge that we've learned so far. So we have this graphic with a vertex point D right in the middle. It forms a line going through point A and C. Get my braille right today. And then it has a ray extending from point D through about the 1 o'clock position. And that's through point B. And the angle ADB, the one on the left, is what, 110 degrees?
Yep.
And the angle on the right, BDC, better be 70 degrees, because going from point A to point C, we turned around, right? We arced all the way around, and we did 180 degrees. So always, always, always a linear pair is going to be supplementary, okay? Now, that's pretty basic in a drawing, but guess what they're going to do? They're going to give it to you in like a story problem. They're going to say, angle 1 and angle 2 are a linear pair. Angle 1 is 57 degrees. What is the measure of angle 2? Your brain has to go, oh, yeah, linear pair. They form a line, 180 degrees. They're supplementary. So I'm going to subtract 57 from 180 and get my answer of 123. So that's what you're going to have to do. They're not going to give you some fancy little drawing. They're going to give you some sort of story problem, and your brain's got to turn on. And remember, a linear pair is always 180 degrees. But that should make sense if you think about, hey, I'm doing a 180. I'm turning around. So a linear pair is always going to be 180. Okay? All right, what I would like you to do for homework.
Weekend's homework. You're gonna make me
I'm-
carry my book.
Well, you said you wanted to listen to the videos and stuff, so I am. I'm going to make you do number 2 through...
Great.
Ooh, I am going to really kill you guys this weekend. I'm sorry, but I want you to really practice everything you've learned so far. You haven't had a lot of homework in a really long time. So I'd like you to do number 2 through 21 on page 119 to 120, all right? 2 through 21 on page 119 through 120. You're going to have to make your way through several drawings. Really, really, really concentrate and think about it, all right? And if you have a study hall, obviously you're going to get it done during study hall. If not, Miss Abby, you got to take the book home.
So page what?
Page 119 to 120. It's going to be in volume 9. You can come back later today and grab it if you'd like. And it's number 2 through 21. Yep, you got Shane. He can help you. I slaughtered him with homework today, Shane. Gave him 19 problems to do. Yeah, it's just angles and supplementaries and complementaries and linear pairs and a little bit of algebra with it.
Okay,
Yeah,
got
but
it.
the big deal is reading those graphics, which Abby's doing awesome at. You must be helping her.
Yeah,
No?
but
Yeah. I know, she's doing it. She's doing it. She's getting them down. She's naming her angles today. I got it. All right, Brian and Stormy, do you have any questions?
No.
No.
Hey, you guys have a good weekend. We'll see you on Monday.
Okay.
All right.
can I come pick up my book later?
Yes, you can pick up your book later.